today's experiment will be on nautical sextant. We'll see to it. First, title of the experiment is Study and Use of Nautical Sextant and Measurement of Horizontal Angle. You might be thinking, what is nautical sextant? This is the completely new instrument for surveying. It is mainly used in with the help of celestial bodies such as stars, some fixed stars, or sun, moon. It can be, this experiment can be performed anywhere as it is a handy instrument. It can be used anywhere, mainly on a ships, because to locate their locations. How? By considering a fixed stars such as celestial bodies, moon, sun, anything. And based on their particular location, they are going to find the vertical angle as well as horizontal angle. In our syllabus, we will be dealing with only horizontal angle. You might be thinking, why only horizontal angle? As we are performing on a ground, so we will be using only horizontal distance. You might be thinking, some of the ships may be on a ocean or a seas. There might be some island or some banks. From that particular reference point, we can trace our locations. If not, then with the help of vertical angle, then we can find out the exact location with the help of nautical sextant. So, aim of the experiment to study and measure the horizontal angle with the use of nautical sextant. It is very handy and say comparatively accurate one. We can't say it is 100% precise or 100% accurate. It is comparatively handy. Based upon the operators, it will be giving the more accurate result. This is our sextant apparatus, which consists of a number of components, which is having a specific function for each component. So, we will be dealing with the components and their functions. First of all, this is our telescope, which is directed towards both the mirrors. And one mirror, if you see here, that is half silver coated. Another one is unsilvered, means not coated at all. With these two mirrors, we will be bisecting the two different object which is far away on a ground, plain ground. This is the function of these two particular glasses. One is half silver because reflection of the full silver image will be reflected on the half silver. The both objects should be coincide together and they should become a single unit like our finger. If it is by coinciding slightly different, then it should not be considered. It should consider exactly a single unit. That's why half silver coated, in half silver coated mirror, we can see the reflection of half image of the another mirror. Then only both objects can see in a single unit. How to adjust the reading then? If you see this one, this is called index arm. This is index arm. And this is index rider. Rider means which is having a pointer to read the reading. The pointer is here. This is our pointer. Pointer is going to read the reading over the index arm. And there is a, here in index arm, we are going to see the degrees, only degrees. And second, minutes will be seen on the index drum. Here is the drum. In this drum, there are 60 minutes. And below, there is a micro minutes that can be read through this sidewise drum. And next, there are some shades for both the mirrors with different sizes. These shades were helpful for when we operate the instrument in a sunlight, because UV rays were very striking your eyes through the plane mirror. So, we are using 3 different shades. If intensity of UV rays are very high, then we use all the 3 together. So, mainly when you operate the instrument in a sunlight. During night, it is not at all required. Any shades are not required. And next, there are another set of shades which is for the fully mirrored or unsilvered mirror. Again, for the same purpose, as both the mirrors are functioning through the UV rays of sunlight. So, it is directly harming our eyesight and unable to see the object. So, that's why we are using these particular shades. There are 3 sets of shades. When UV rays are very high intense, then we use all the 3, or else we will be using single. And below there is an handle. This is a handle by which we can operate the instrument. So, it is called as handy instrument. It is purely, its accuracy is mainly depend upon the operator precision. So, this is handy. Mainly this particular instrument is used to find the horizontal angle as well as vertical angle of with reference to celestial bodies. What is the procedure is? Procedure is when we bisect two objects, there are two objects, that is right side one ranging rod is erected and the left side there is another ranging rod is erected. So, you can see the tape. When you measure the horizontal distance between two objects, we need to find the center point of the object. That center point is, I am standing on exactly center half of, we already measure the distance, and with respect to distance I am standing on exactly center of the both the objects. So, this is how we need to hold in a palm. If this, look at this particular, if I open the thumb upside, it index arm cannot be moved. So, it need to be holded in this particular direction. So, this is how we hold it. Now, I will turn towards, there are two mirrors, one half silver coated, one is fully. So, first I will see the front image, parallelly in half silver I can see the back side image. So, that is why I can find the exact angle. So, I will turn to index arm to 0 reading first, now it is on 0. So, I will see the object and I will turn the index arm, I am turning again, turning. Yeah, it is coinciding exactly now. It is coinciding means both the rear pole, I mean rear ranging rod and front ranging rod both are coinciding exactly on a half silver coated. I can see the front image and back image both in a same unit. So, it will be showing a single unit. Then I will be reading the angle on an index arm with the index pointer, that is 30 degrees, 31 minutes and 2 seconds. This is the horizontal angle of this particular two objects. Similarly, we need to take care of two more readings, and with the three set of a reading we can find the mean of the horizontal angle between two objects as I did it right now, and we can get the horizontal angle by using a sextant. This is how we perform the things. If you are operating in a sunlight, then we have a three shades which is going to protect your eyesight from the UV rays. One more thing, when you want to find the horizontal angle with respect to celestial bodies, if you are operating in a daytime, then sunlight, that is your celestial permanent body. With respect to celestial body, we can find the horizontal angle of that particular object on a ground. So, then we will be taking this particular direction, telescope will be directed towards the sunlight and parallelly we will be moving the index arm. Whenever you move the index arm, then that particular point, both points are going to coincide. That value will be known as a vertical angle, but as per your syllabus vertical angle is not there, still I am explaining for extra knowledge point of view. Then we read the reading same. At that time we may use these shades for the fully mirror or half silver coated mirror. So, this is how we utilize this particular equipment for performing horizontal angle as well as vertical angle. So, further calculation we see to it on a class. In field we have conducted the test and we observed the readings, we have seen that one. Here station point is 0, where our person was handling the equipments, that is sextant. Angle of AOB is given by observation reading 30 degree 31 minutes 2 seconds. We have conducted 3 set of readings at that same point, variation in the second value, that is 2 seconds and 3 seconds. So, we consider all the 3 values and index error was this one. That means, whenever you take a pointer, index initially index arm showing the minimum reading, that is 0 degree 0 minutes and 3 seconds. So, we need to subtract that one, that is observed reading, that one this set minus index error is equals to corrected reading. That is why we have recorded the corrected reading also. Why we need to record the corrected readings? Because whenever you operate the instrument with the age or with the usage, index arm or instrument have a minimum error. That error is pointed out by seeing the drum. So, drum error initially it is this one, need to subtract from the reading values. So, we got a corrected values, that is 30 degree 30 minutes and 59 seconds, 30 degree 30 minutes and 59 seconds, 30 degree 31 minutes and 00 seconds. So, these are the corrected readings and this is the formula. So, this was a very simple experiment, and this nautical sextant is also used mainly in ships. Why in ships? Because they need to see their location. How they are going to trace their location? By seeing the celestial bodies. Celestial bodies are star, galaxies and moon, sunlight. Whenever they travel in an ocean, they see this instrument, handy instrument, and they see the moon or sun or some permanent star, and they trace their locations by using the simple input. As well as we also find out the horizontal angle, that is simple on ground or off the ground, we can find the horizontal distance also. This is how we worked out with the nautical sextant. So, this is our final conclusion.